The horseshoe crab is an animal that is not often thought of. You may have seen it in a textbook or hung up as a fossil in a museum, and there is good reason for this. The horseshoe crab species has been around for approximately 455 million years, predating even the supercontinent Pangaea itself. In today's world, nearly 250,000 horseshoe crabs are caught annually. You may be wondering why this is. What makes these ancient creatures so important? Well, if you've received an injection of any kind in the past 60 years, you have benefited from the biology of these creatures. The secret lies in their blood, which runs blue due to its use of copper as an oxygen transporter instead of iron. The real magic, however, lies with a compound called Limulus amebocyte, and the discovery of this compound changed the world of medicine forever. In this video, we are going to explain the importance of this compound, its applications, and the limitations that come with humanity's reliance upon it.
Hi, my name is Ozzy, and I'm going to talk about why LAL testing is so important for all of us. LAL testing is used for bacterial endotoxin testing to determine the abundance and the concentration of bacterial endotoxin from a given sample. It is the most popular method for bacterial endotoxin testing compared with the rapid pyrogen test and also the monocyte activation test. LAL testing is usually used in the pharmaceutical industry, as the endotoxin is a type of pyrogen. The LPS on the cell wall of the bacteria will trigger the human immune response and cause inflammation, or what we call fever-inducing molecules. So, why it is more popular or better than other bacterial endotoxin testing? LAL testing is a fast testing. It just needs about 30 minutes to conduct the result. It's easy to perform, it's sustainable, humane way without killing the horseshoe crab, and lastly, more sensitive and obvious than the other BET. We just have to see whether there are gel clotting for a positive result. Also, compare it with the traditional rabbit test, which it needs much more time to get a result. It is not humane because it will harm the rabbit, it's not sustainable and not easy to perform, as there are lots of uncertainty to trigger the immune response inside the rabbit body.
We will now discuss the chemical pathway of the coagulation cascade produced by LAL. The process is classified as a serine protease zymogen cascade. The main factors that influence the process are factor C, factor B, and the pro-clotting enzyme. Factor C and B are zymogens, which are inactivated enzymes. These zymogens are present in the blood at all times, but only activate in the presence of bacterial endotoxin. Factor C is autoactivated, which means that upon endotoxin exposure, factor C cleaves itself. The activated factor C then cleaves and activates factor B. Activated factor B then cleaves and activates the pro-clotting enzyme, which becomes the clotting enzyme. The clotting enzyme then cleaves coagulogen. Coagulogen is the protein responsible for the clotting effect of LAL. Coagulogen aggregates into insoluble small molecules called coagulin, which form the gel clot assay. The protein shown is 1,3-beta-D-glucan, which is present in the cell wall of yeast and other fungal species. This protein is also part of the activation of the pro-clotting enzyme in clot formation. This overview gives a more full and complete picture of the Limulus clotting mechanism. The presence of 1,3-beta-D-glucan activates factor G, a serine protease zymogen, which, like factor B, is capable of activating the pro-clotting enzyme, triggering the activation of coagulogen. The protein shown is coagulogen extracted from Tachypleus tridentatus, also known as the Japanese horseshoe crab or the tri-spine horseshoe crab. Coagulogen consists of an A chain, shown in green, a B chain, shown in orange, and a peptide C, with a total sequence containing 175 amino acid residues. Upon activation by the clotting enzyme, peptide C is released and chain A and B of coagulogen are linked by 2 disulfide bonds.
During the extraction of blood, about 30% of the horseshoe crabs used don't survive the process, and it isn't known if those that are returned back to seawater live healthy or long enough. The pharmaceutical and medical companies that fund and carry out this process claim that horseshoe crabs are treated as humanely as possible and with care. However, organizations that voice for animal life, such as People for the Ethical Treatment of Animals, also known as PETA, think otherwise. They suggest that there are other non-invasive ways to do LAL testing. Due to the high demand for the collection of blood and the use as bait, it is a fear of endangering horseshoe crabs and eventually leading up to its extinction. Efforts have been made to create potential solutions to preserve this billionaire species. Innovations in aquaculture for harvesting blood are being implemented, such as indwelling catheters to ensure low-impact extraction and a 100% survival rate outcome. Also, a creation of an LAL analog by using recombinant factor C as a synthetic alternative is in the process, yet these replacements are still under work. Meanwhile, as a human being and an outsider, it is recommended to be mindful of our waste and what can end up in the ocean. Being considerate of the other species surrounding us can make an impact and help maintain their preservation.